From abstract proofs to physical illumination. Unlocking the hidden geometry of fields. The derivation sheet serves as the master blueprint for a narrative that moves from pure logic to the tangible physical forces shaping our universe. It provides the rigorous mathematical framework that allows us to understand how vector fields scale and spread throughout space. This technical foundation is brought to life through two distinct lenses. The sequence diagram, which tracks the learner's chronological journey from discovery to application, and the state diagram, which highlights the purposeful transitions that turn abstract calculus into physical intuition. The path of discovery. The journey begins at the core of the derivation sheet, establishing the fundamental rules for how fields behave when they are scaled up or down. The sequence diagram illustrates this as a linear progression. First, proving a core identity, and then immediately moving to interactive tools that provide real-world verification. This ensures that the math is not just a theoretical exercise but a confirmed reality for various field types, such as those that radiate outward or those that remain constant regardless of position. Expanding the horizon. Once the foundation is set, the narrative shifts toward generalization. The derivation sheet proves that the way a field spreads out, its flux density, is inherently tied to the number of spatial dimensions it occupies. The state diagram identifies this as a critical transition, serving as a visual and mathematical bridge. It allows us to step outside of our standard three-dimensional world to see how field geometry changes in simpler or more complex spaces, showing that the spreading of a field is a predictable consequence of its dimensionality and its original scaling power. The physical climax. The true significance of the derivation sheet is revealed when these abstract concepts are applied to the physical world, specifically to the electric field of a point charge. Here, the sequence diagram and state diagram converge on the concept of physical realization. By applying the derived identities to a point charge, the narrative reveals a phenomenon known as the steepness drop. Through a specific mathematical transformation, a field that normally decays rapidly as it moves away from its source is converted into a field with a steady, constant magnitude. This process unlocks a hidden pattern. While the original field appears to have no spreading, divergence, in empty space, the transformed field reveals a non-zero glow that perfectly mirrors the local electrostatic potential. This final stage of the narrative proves that the rules of scaling and homogeneity are not just mathematical curiosities, but the fundamental constraints that dictate how energy and flux are distributed across the geometry of a field.